Okay, it's time to look at independent events, and in probability this does have some significance, and it's our job in this section to establish whether two events are independent or not. Now you know what the word independent means, free, not relying on, so that's exactly what independents are about. Events are independent if the outcome of one has no impact or influence on the probability of obtaining the other. Okay, so the classic example in what we've looked at so far is the situation where we're taking, say, marbles from a bag, and if we put the marbles back in, so events involving replacement, well, they're independent because it doesn't matter what I took out on the first pick, because I put it back in the bag, I'm going to have exactly the same number of marbles, same colours. So events involving replacement are independent. Whereas events involving selection without replacement are not independent. So, for instance, if I've got a bag of balls here, I've got 3 blue and 2 green, and I take a green out. Now, the probability of so I take a green out. Now there's only one green. That means, because I've got a green out here, that means that the probability of a green or a blue on the second pick has been changed. It's been affected by the first pick. So those events, pick 1, pick 2, or picking out a green on the second, picking out a blue on the second, not independent of the first. So there's an example of what independent events are. Okay, so we're going to go and have a look at how to establish this, because that's what we're going to be asked to do. Find out if two events are independent or not of each other. So sometimes it's pretty obvious, isn't it? Just like the example I gave. If I flip a coin or roll a die, it doesn't matter what I did the time before. The die doesn't remember if you rolled a 6 before. He's going to just roll his thing out again. It's not going to make any difference. They're independent events. Whereas events like the one I've just mentioned, or if perhaps in a sporting contest, it does matter what happened before. It does matter if I won the game before. I'm more likely to win it the next time around. And they're not independent of each other. So more real life examples will show independence. Right, so let's have a look at a Venn diagram here in front of us. And here we've got, I've just sets A and B. We don't really know what they are. It doesn't really matter for the purposes of what I'm explaining. This is set A here, and this is set B. So I've got 5 elements in set A. I've got 7 in set B. I've got 3 that sit in the middle of the 2. So what I'm calculating here is the probability of A. Now the probability of A, right, out of those 9 elements, 2 plus 3 plus 4, the probability of A is 2 plus 3, there's 5 in A, out of a total of 9. So the probability of A is 5/9. But the probability of A given B, remember this means given B. Now, if I know, if I'm only selecting from B, now I've only got 7 to choose from. The probability of A given B is 3/7. Now these probabilities are not the same. So putting in, as I note here, as putting in the condition of B has changed the probability. So it went from 5/9, so the probability of A 5/9. The probability of A given B, it's 3/7. It's changed. So putting in the condition of B changed the probability. Therefore, logic suggests there, doesn't it, that these two events are not independent. If they were independent, it wouldn't have mattered that B happened before. I still would have got 5/9 here. So if these two numbers are different, for probability of A and probability of A given B, if those two values are different, then they're not independent. If they're the same, then they are independent. Okay, just scrolling down, if you're looking at another example, I apologise if I'm going too fast here. You might want to pause and just, the way to run through this would be to perhaps listen to what I've got to say and then pause the screen and write down the notes and then go for it again. So continuing now, we've got a bag here. I haven't chosen white balls this time sensibly. I've got 1, 2, 3, 4 green and 3 blue balls. Marbles actually. 2 marbles are picked out. So this is the scenario. 2 marbles are picked out. We're selecting 2, one after the other. So with replacement, if I replace the marbles, now let's have a look at the probability of getting a green marble. 1, 2, 3. There's 4 out of 7. So the probability of a green is 4/7. Now if I put that green, so I took this green out, if I put him back in, the probability of okay, sorry. Yeah, so I put him back in. Then the probability of, and then look at the probability of a green given that a blue happened the first time round, then the probability is still 4/7 because that blue came out and went back in again. So it didn't make any difference that the blue happened. Didn't matter what happened the first time because the thing got replaced. Now have a look at without replacement. The probability of a green is 4/7. Again, yeah, that's the first pick. The probability, now let's take a blue out. So blue's happened. So blue comes out, doesn't go back in. I've only got 2 blues there now and 4 greens. So my probability of green after a blue has been selected and not replaced is 4/6. Not equal, so not independent. Here, 4/7, 4/7, these are equal, so therefore independent. So what we do to test is we find the probability of A or B or whatever it is, and then we see if it changes given that the other thing has happened, right? It's given that the other event has happened. Did that affect the probability? Did it change it? Okay, so take those notes down and then scroll down the page. Okay, moving on. If two events A and B are independent, this is just sort of summarizing the notes from what we've just discussed. The probability of A intersection B, or A and B, will be equal to just the probability, the product of those probabilities, because there's no intersecting region to worry about. Probability of A times the probability of B. If they're independent, this will be the case. And the probability of A given B will just be the probability of A if they're independent. Just like up here, the probability of G was the same as the probability of G given B. In this case, the two events are green and blue marbles. It didn't matter that blue had happened before. It didn't matter. So that means that they're independent. The probabilities did not change. And the other way around, probability of B given A will be the same as probability of B. It won't change it. Okay, pause and write down, and I'll scroll down the page. We're about to do now an example, and so you might want to write this example out. A selection of 10 mobile phone offers includes 4 with free connection, 5 with a free second battery, and 1 offer has both a free connection and a free second battery. So we're going to let A be the event choosing a mobile phone with free connection, and B is going to be the event choosing a mobile phone with a free second battery. Right, so summarize this information. Summarize, doesn't like my spelling, this information in a Venn diagram. So Venn diagram, get our sets A and B in place and start to fill them in. So A is the event choosing a mobile phone with free connection. Right, but the smart thing to do, isn't it, is to put in the intersecting region first. So 1 offer has both free connection and a free second battery. So I've got 1 in there. I've got 4 with free connection. So free connection, that's in there, and I've got 5 in there with a free second battery. 4, 5, 10. The total is 10. So that would be the look of our. Oh, actually, sorry, that's incorrect, isn't it? That's incorrect. This here, I've got 4 with free connection. That includes, I've got 5 there with the 4 there. So I've got 1 here. I've got 6 at the moment. I've got 6 with a free second battery, but I only want 5. So that's an error. There's 4 in there. So now I've got 5 with the free second battery. I've got 4 with the free connection. I've got 1 who gets both. That's 3, 4, that's 8. So I've got an outside region. And 2 offers don't have either. Right, so what's find the probability of A? A will be 4, 3 plus 1, 4 out of 3, 4, 8, 10. 4 out of 10, or 2/5. Now we're going to test for independence. Find the probability of A given B. Okay, so given that B has happened, so this is my sample space, which is 5. What's the probability of A? A is the 1 bit of that, so that's 1 over 5. So the probability of A is 2/5. The probability of A given B is 1/5. That's changed. So are they independent? Answer that question. The answer is no, they're not independent, because if they were independent, that would not have changed. So state whether two events are independent. No, they are not. 2/5 does not equal 1/5. Okay, so that's it in a nutshell. Independent events. Take down the notes, and I'll see you in class, and we'll do our last exercise, exercise 8G, from the work requirements, and that'll round out the week, finishing the topic off with something new to do next week. Okay, cheers.